Hey, what's up, Logic fans? It's Ash. Today we're going to hit section 3.7 of the text, our 7th section on propositional syntax. Here we look at advanced conditional proof techniques, and in particular the technique of nesting conditional proof assumptions within one another. Let's rock. Alright, so nesting is an advanced sort of application of conditional proof. So what we're going to do in this video is we're going to take for granted everything from 3.6. So if you haven't gotten 3.6 down, you should stop now and go check that out, because I'm going to be assuming all of that material. I think the best way to explain nesting is via example. So let's go ahead and try one of these together. So take a look at this theorem here. And let's suppose that you were to prove it using conditional proof. All right. What would your assumption be, and what would you be looking for on that assumption? Okay, so hopefully you can look at that and you can say, okay, my assumption would be A, and what I would be looking for is this guy right here. Okay. And if that doesn't make sense to you, again, you need to go check out 3.6. What's interesting about this particular case is that now that we're looking for this, what we're looking for is itself another conditional. And so we could make yet another assumption, and what we would be looking for there, or rather what we would assume there, would be B, and what we'd be looking for is A. So let's do this out on a chart and see what it looks like. Okay, so let's take a look at this. Now, we've noted that we're trying to prove this theorem, and we're going to use this nesting idea to do it. So what would your first line look like if you were to use CP? Well, we noted that you can assume A, right? So we're going to do 1A, and from that assumption, right, we're going to be looking for if B, then A. Just like this. Okay, and now what we're doing is we're looking at what we're looking for, which is a conditional in this case. What we're looking for now is a conditional. And so looking at that, we can go, oh, you know what? Maybe I can make another assumption within this particular assumption. So I'm going to make yet another assumption, and it's going to assume B, right? And then I'm going to be looking for A, as we noted. So let's get that on the board here. That's going to be yet another assumption, and that's A. Now, you're familiar with the idea of using multiple assumptions. For example, when we use conditional proof to prove a biconditional, you use CP twice, once to get each conditional, the left to right direction and the right to left direction. That's fine, and it's similar to here in the sense that you're using conditional proof twice. The difference is that when we used it to prove a biconditional, we would make an assumption, go through, close out that assumption, discharge it, then make a new assumption and do it, okay? Here what we're doing is very different. Here we're making an assumption, we're not closing it out, we're not discharging it. Within that assumption, we're making yet another assumption. And it behaves in basically the way you would naturally suspect, but there is that difference. And so let's go through how this works. Your object now is from to generate A, okay? So see if you can generate A here. Pause now. Okay, well, it might have been a little bit tough, but you do have A available. It's right here, okay? This is something you've assumed. And we're going to use this little trick I use when something you have is available up above, but you need it sort of down below here. I just use this little double negation trick. So it's double negation on one. Then what we're going to do is we're going to do double negation on that yet again. And there it is. Now I've sort of, as it were, moved this guy to down here. And now that I've got the A below the B, what I was looking for, I can discharge this assumption. So if I were to discharge this assumption right here, what would I get? I'm discharging this one. What goes here? What goes here in line 5? Okay, well, it follows the exact same pattern as before. What you're going to get is if B, then A, right? So what you're going to get here is the thing you assumed, arrow, the last thing you showed, which was that. And then what you're going to do is you're going to call that CP 2 through 4. Okay? All right. And then we look at it and we say, okay, I've discharged this assumption. I still have an open assumption that I haven't discharged yet. I need to discharge it. Fortunately, it doesn't look like I have to do any more work. I've already got what I needed from this assumption. So having obtained what I needed from this assumption, I'm now going to discharge this assumption. And so on line 6, what would I get, right? I'm discharging this assumption, and this is the last thing I got. So what goes in line 6? Okay, it's just the theorem, right? Because, right, this was the thing I assumed, it goes here. Then I write the arrow, then I write down the whole thing, whatever it was that I got last, which was this, if B then A. Okay, and then I'm going to justify that CP 1 through 5. Okay, so this assumption ranged through here. So that's CP 1 through 5. And it's an interesting situation where you've just sort of stacked on multiple assumptions, but it can really help you because, as we saw in this example, it gets you two things on the board. We had nothing on the board to start with, but then we had A and then we had B. And we had a goal. From that, we had to get A. Okay, so it's a really useful technique once you've mastered it. One thing I want to point out here is that notice that we closed this assumption first. Right here is where we closed it out, this particular assumption, and then we closed this assumption. And that's always going to be the order, okay? You're going to close out your newest assumption first and your earliest assumption, the first one you made, last, okay? And so like if you had 3, you would close out the third one first, the second one second, and the first one last is when you would close it. So it is always going to follow that pattern. Let's look at some more examples. Okay, so I want to make sure we're on the same page here. Okay, let's try this one, and I'm going to give you a little bit of a start here. So in this case, what would your initial assumption be if you were to use CP to prove this theorem? Okay, so you're looking at it, and you notice it's a conditional, so you would assume A, right? So we're going to write A, and that's going to be a sum, and you're looking for not B or A, just like this, okay? Now, we can nest an assumption here, but it's not entirely obvious what the assumption we should make is, okay? So we're going to make another assumption, and you can, but my problem for you is for you to figure out what I should assume here and what I would be looking for. So pause now and see if you can figure that out. Okay, so what you can do here is you can picture not B or A as a conditional. And as a conditional, by impla, it would be if B then A. So you would assume B, and you would be looking for A now, okay? And that's sort of, again, these advanced sort of techniques, and we went over that kind of idea in 3.6, okay? So you can look at the thing you're going. In the last example, the thing we were looking for here was explicitly a conditional, and so we knew what to do right away. In this case, we thought, man, you know what? It'd be nice to make another assumption to get something extra on the board that I don't have, but I just don't know what assumption to make. Well, think about the thing you're looking for in terms of a conditional, and that'll light the way for you. Okay, that's the strategy. Okay, so now I'm looking for A, and this is now going to be very similar to the last one. So we need to bring our A down. You won't always have to do that, but in this case you do. So we're just gonna use our little double negation trick here, and there we have it, no problem. All right, and having obtained what I wanted from this particular assumption, I discharged this assumption. So what am I going to write in line 5? Okay, so in line 5, what I'm going to write is if B, then A, right? So it's the exact same strategy from before, right? So it's the first thing I assumed, arrow, the last thing I got, which is A, and now this assumption has been discharged. What's interesting here is that in this case, unlike the last one, okay, where we were just looking for a conditional, here we're not looking for a conditional, we're looking for a disjunction. So now we've got to do a little bit of more work before we discharge this assumption. We got to get what we're looking for, and what we want is this disjunction. So we're going to get it, of course, by doing this, and that's going to be impla on 5. And I didn't justify this. This was CP 2 through 4. Okay. So now that I've got what I was looking for from this assumption, I can discharge this assumption. And what do I get when I discharge this assumption? Well, I'm going to get the first thing I assumed, arrow the last thing I got. So let's get our arrow here, and then we're going to put the last thing we got, whatever it was, right in there. And so we'll just take that last part and bang. Okay, and that's going to be CP. What will it be? CP what? Justify it. 1 through 6 in this particular case. Don't need this extra line. Let's get rid of that. And bingo. Okay, so that's QED. So that's a really interesting proof of this theorem. And I just wanted to show you that you can think a little bit about what you're looking for in terms of a conditional to get yourself to, see what else you could assume and do your sort of nesting idea. And then sometimes you have to do a little bit of playing with it after you discharge an assumption to get something into a relevant form before you discharge another. Now, notice in this particular case, okay, and I want to make this point, you could have discharged here. So like it's legal to do that. So let me show you what I mean here. Okay, let's suppose you had discharged right here at this point. You said, you know what, I'm going to discharge now. Well, you would get 6. You would get if A, then, right? So you'd get the first thing you assumed, arrow the last thing you got, which is this, all right? And you can kind of clean it up afterwards is the point. You could do it like this, and that would be CP 1 through 5. And now you don't have this particular thing, but you can get it pretty quickly, right? So you can just sort of do impla on it. And remember, impla is a rule of replacement, so you're allowed to do this. And you would get it just like that, all right? And that would be impla on 6, and that would also be a perfectly fine way of doing things. So as you advance with conditional proof, one thing that you're going to want to look at a lot is like, hey, what if I were to discharge this here? What if I were to discharge that there? Okay, and as you see more and more examples of that and start playing with that, you'll refine your instincts about those sorts of advanced ideas. But for beginning students, mostly you want to kind of follow the ideas I'm setting out, which is make sure you get the thing that you're looking for and then discharge at that point, no earlier, no later. That's not a rule of syntax that you have to follow. It's not like a hard rule. It's just sort of like advice for being able to carry out the process effectively and actually solve the problems, okay? All right, let's spill onto another video and look at some more examples of conditional proof nesting. So check out 3.7b.